Hey kids, Miss Butra here, and this video is over square roots. Now, you guys already know what square roots are. They are the root of a number of what you would multiply by itself to get that number. So we're just going to do some practicing then. We want to simplify. Let's simplify the square root of 16. If I said that, you would tell me 4. It's not plus or minus 4 because I didn't say plus or minus the square root of 16. I said implied positive square root of 16. So your answer is positive 4. If I want the square root of 12, I'm implying that I want the positive square root of 12. We can break that down. What you want to do, some of you have learned to make a tree, and so you go 12 is 2 times 6, and 6 is 2 times 3. And then you circle your pairs of 2's and you say 2 root 3. But a way that I think is easier is take your square root of 12 and just rewrite it as I'm going to actually do it over here. The square root of two numbers multiplied together. And you have to think, are there any perfect squares that will fit into 12? And our perfect squares are 1 and 4 and 9, 16, 25, 36, 49. Do any of those go into 12? And 4 does. So 12 is 4 times 3. When you break it into the product of two numbers, and one of them is a perfect square, we can say that's the square root of 4 times the square root of 3. And the square root of 4 we know is 2. So that's 2 root 3. And it's a bit faster to do it that way, I think. All right, let's do another one. Let's simplify 3 root 2 times 4 root 3. When you have two mixed parts like this, we're going to multiply the 3 and the 4 together and get 12. And we're going to multiply the square root of 2 and the square root of 3 together and get the square root of 6. So when you're multiplying mixed radicals like that, put the whole numbers together, put the radicals together. All right, let's simplify the square root of 5/4. When you've got a fraction under a radical, you can split it up into radical of the top, radical of the bottom. And since this one has a perfect square on the bottom, that's square root of 5 over 2. Now let's do another one, square root of 6 over 5. So now this one is the square root of 6 over the square root of 5, and either of those are perfect squares. And the general rule in math is you cannot leave a radical in the bottom of a fraction. You cannot have a square root as your denominator. So we do what we call rationalizing the denominator. You're going to multiply the numerator and the denominator both by the radical, only the radical that you have in the bottom. So here we've got the square root of 5. When I do it to the top and the bottom, I'm multiplying the top and bottom, so it's like multiplying by 1, so I'm not changing it. I'm just putting it in a different format. So what we have in the top is the square root of 6 times 5, which is 30. And in the bottom, I have, if you think about this, that's the square root of 5 times 5, which is 25. And the square root of 25 is 5. When I do the square root of 5 times the square root of 5, I always just get 5. And it works that way for any square root. And then we need to look at that square root of 30 and say, can we simplify that? And 30 is 2 times 15, and 15 is 3 times 5. None of those are perfect squares, so we can't. We're done. Okay, this next one is going to be a little bit tricky. It's going to be something new for you. We need to fix 3 over 2 plus the square root of 2. Because I don't want to have a radical in the bottom of my fraction. And so I put this little pumpkin with the pie in it in the corner, because when you guys ask me about this, I'm going to say, refer to the part of your notes with the pumpkin pie. And so you can either look at the video and find this page, or you can write it down in your notes so that you can look at it, but I don't want to have to repeat these directions 47 times. All right, so when you have 2 plus, or a number plus a radical or minus a radical in the denominator, I have to multiply the numerator and the denominator by what we call the conjugate of the denominator. The conjugate of 2 plus the square root of 2 is 2 minus the square root of 2. So the conjugate is the same, except the sign changes, the sign in between here. So then in the numerator, I have to multiply it by the same thing to keep it equal. So then on the top, I'm going to distribute. 3 times 2 is 6. 3 times negative square root of 2 is minus 3 root 2. In the denominator, I'm going to FOIL. Very important that you FOIL it. 2 times 2 is 4. 2 times minus square root of 2 is minus 2 root 2. Positive square root of 2 times 2 is plus 2 root 2. And the positive square root of 2 times the negative square root of 2 is going to be minus 2, right? Because that's the square root of 4. But it is, you have to remember that it's minus. So now look here, because this is negative and this is positive, they're going to just cancel each other out. That's why we multiply the numerator and denominator by the conjugate, because we want the radicals in the denominator to cancel out. So we have 4 minus 2 is 2. I have 6 minus 3 root 2 in the numerator, and I have 4 minus 2 is 2 in the denominator. And that's it. That is the rationalized version of 3 over 2 plus the square root of 2. All right, so remember, pumpkin pie if you need to know how to do this again. All right, so that's simplifying now. What if I said solve? If I say 3x squared equals 21. That's different from simplifying. Now I want to know what can I plug in for x that would make this true. So I'm going to divide both sides by 3. And 21 divided by 3 is 7. And then I'm going to take the square root of both sides. Now, this is when you want to do plus or minus the square root of 7. Because if I plugged the square root of 7 in here for x and squared it and then multiplied it by 3, I'd get 21. If I plugged negative square root of 7 here for x and squared it, I'd get 7 times 3 is 21. So they both work in this equation. Remember, simplifying, we aren't going to do plus or minus. When we're solving, that is when you do plus or minus. Let's do a couple more. How about 1/3 x squared equals 4? All right, first thing I want to do is multiply both sides by 3. So I have x squared equals 12. Then I want to take the square root of both sides. Don't forget your plus or minus. That's the first place people are going to lose points. And then I need to make sure and simplify, because the square root of 12 can be broken down into the square root of 4 times the square root of 3. And so that is plus or minus, and then the square root of 4 is 2, and then the square root of 3. The plus or minus goes on the outside. We don't move it to in between. That would be saying something altogether different. This is saying positive 2 times the square root of 3 and negative 2 times the square root of 3, not 2 plus and 2 minus. It's different. So make sure you have it out in front. Okay, here's another equation to solve. 6x squared plus 3 equals 16. Remember, we're undoing PEMDAS, so we're going to take away 3 first. 6x squared equals 13. Then we're going to divide by 6, so x squared equals 13 over 6. Go ahead and leave it in fraction form. Then we're going to take the positive and negative square root of 13 over 6. Sorry about that. We'll write it in orange. 13 over 6. Which means that we have a radical in the denominator, so that's going to be plus or minus the square root of 13 over the square root of 6. Then we have to rationalize, so multiply both by the square root of 6. And the square root of 13 times the square root of 6 is going to be the square root of 78. And you just have to leave it like that, the square root of 78. And then the square root of 6 over the square root of 6 is 6. So we have plus or minus square root of 78 over 6. Okay, here's another one that's going to get some of you on the test. I promise it will. It will. So maybe don't let it be you. Let it be that other guy who didn't actually watch the video. When I set this up and I say solve for x, I want to figure out what x is. So some of you are going to see this and you're going to go, oh, FOIL, I need to FOIL, I need to FOIL. If you FOIL, you're going to have more x's in your equation than just one. And that makes it even harder to solve for x. So don't FOIL. You are going to solve for x, so you're going to undo everything around x. The first thing we're going to undo is this 3. So we're going to divide both sides by 3. 27 divided by 3 is 9. Then we're going to undo this squared. So x plus 1 equals plus or minus the square root of 9. That means that x plus 1 equals positive 3. It also means that x plus 1 equals negative 3. And I wrote it as two separate equations because sometimes when we put plus or minus 3, we don't realize that that's two different numbers that we're talking about. So go ahead and write it as two separate ones. So x plus 1 equals 3, that means that x equals 2. And if x plus 1 equals negative 3, then that means x equals negative 4. So we have two answers. X is equal to 2 and negative 4. There are two things that we could plug in right here for x that would make this true. All right, this next bit is about falling objects. There's an equation for falling objects that you will have to memorize, and that equation is h equals negative 16t squared plus s. H stands for the height. T stands for the time. And s is the starting height. So h is the height at time t, but s is the height where you started before you fell. All right, so let's do an example. All right, when will I hit the ground if I fall from a 64-foot cliff? So here's a 64-foot cliff. Here's me. Ooh, I fall, splat. All right, how long will it take for me when I leave the cliff to when I hit the ground? How long will that take? All we have to do is take our equation, h, our height. So when we're done falling off the cliff, our height is 0. Negative 16 t squared, I don't know t, I'm looking for t, plus s, my start height was 64 feet. All right, so I'm going to solve this. So I'm just going to move the negative 16t squared to the other side. Positive 16t squared equals 64. Divide both sides by 64, and I get t squared equals 4. And take the square root of both sides. T equals plus or minus 2. Now, because this is a word problem, and I'm not going to be falling back in time, although that would be really cool, we're just going to go with the positive and say our time is 2 seconds. I guess it would have helped if I'd have said t is time in seconds. So add that in your notes. Time in seconds. 2 seconds. That's a pretty short fall. Okay, and this last bit of our notes today is all about a formula you know and love, the Pythagorean theorem. A squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse of a right triangle. So, let me tell you a little story about my parking spot. All right, look at my lovely picture. This orange thing here represents the school building, and this white part is the sidewalk. And then the little white lines over here are the parking spots, so parking lot. So suppose I'm parking right here. Right here's my little car. And I come into school, and I get out. And if I have to walk along the sidewalk, I go this way, and then I go this way. And this is 37 feet. And this is 25 feet. But sometimes I'm in a hurry, and I don't want to walk across the sidewalk. So I just cut across the grass. Boom. Like that. Okay? And I want to know, how much shorter is my shortcut? How many feet am I saving by taking a shortcut? All right, so in order to find out how much shorter the shortcut is, I first need to know how long the shortcut is. And I can do that using my favorite Pythagorean theorem. 37 squared plus 25 squared equals x squared. All right, so let's figure out what x is. 37 squared plus 25 squared is 1,994, which means x is the square root of 1,994. It would be plus or minus, except for, once again, I'm not walking back in time, so we're just going to go with the positive. And since this is a real-world situation, we don't really want to give our answer in simplified radicals. We want to give it in feet. So go ahead and punch it in your calculator and get 44.654 feet. All right. That's how short, or how long or how short, whatever my shortcut is, 44.654 feet. My question is, how much shorter is the shortcut? So I have to say, well, how long was it in the sidewalk? The sidewalk path is 37 plus 25, which is 62 feet. So if I took my 62 feet and I subtract the 44.654 feet, I'm going to get a savings of 17.346 feet. So it is 17.346 feet shorter. Yay, that's a lot of feet to save. So see, it's worth it to cut through the grass, except when it's raining and it's muddy and then it's gross. All right, that's it for this video, and I'll see you in class. Hopefully you remember to watch it this weekend. If you didn't, you're watching it Monday, but whatever. I'll see ya. Bye.